Our nearest star neighbor, Alpha Centauri, is only 4 light-years from Earth, and although that is very close in the grand scheme of things, we cannot simply borrow a little milk. With our current technology, the trip would take tens of thousands of years, but there are plans for small unmanned probes that could get there in just 20 years. Now, a German theoretical physicist has detailed a method to use magnetic sails as a braking system, to reduce the speed to a cruising speed once they get there. Last year, some ambitious space travel plans were presented as part of Breakthrough Starshot, a show headed by iconic physicist Stephen Hawking, and businessman Yuri Milner. The idea was to accelerate small spaceships, about the size of a CubeSat, using a laser propulsion system like a light sail, and send them to Alpha Centauri. This technique has the potential to make nano spacecraft reach approximately 20% of the speed of light, allowing it to travel to the Alpha Centauri star system in just decades rather than millennia. But the acceleration is only half of the equation. Without braking systems it will be a flying visit, since the spaceship makes its way without being able to cover many of the places of interest. Braking systems for these types of boats are a challenge. The space and weight on board are extremely limited, and without friction in the interstellar medium it is difficult to brake an object that moves at about 60,000 kilometers (37,000 miles per second. So Claudius Gross, professor of theoretical physics at the Goethe University in Frankfurt, explained in a new document how magnetic candles could be used to slow down these spacecraft. The sail is composed of a superconducting loop that can be deployed to a diameter of approximately 50 kilometers (31 miles). A leak-free current is induced to create a strong magnetic field in the middle of the cycle, and charged particles would be reflected in that magnetic field, gradually reducing the speed of the ship. Interstellar space is extremely empty, with a density of 0.005 to 0.1 particles per cm3, but according to Gross's calculations, the system should be able to function even with such a low particle density. That said, the ship would need to weigh less than 1,500 kilograms (3,300 pounds) and travel relatively slowly, much slower in fact, than 20% of the speed of light originally proposed.